Hey guys, so for number 56, we're going to solve the equation by using the quadratic formula. So first and foremost, we have to know what the quadratic formula is, and it is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now there is a link in the description for a very annoying song that will traumatize you, but it will help you remember the quadratic formula for life. So go ahead and check it out if you have some spare time. So this quadratic formula and the a, b, and c all refers back to the form that this equation is in, which is the ax squared plus bx plus c, in which our a here equals 1, our b here equals 12, and our c here equals 21. So now we just got to plug these values in for the variables inside of the quadratic formula and solve. So we're going to have x equals the opposite of b, which is 12, plus or minus the square root of b squared minus 4 times a, which is 1, and c, which is 21. That's going to be all over 2 times a, which is 1. So from here, let's go ahead and simplify. I recommend simplifying the radicand first, meaning whatever's under the square root. In this case, this is actually called the discriminant. So let's go ahead and solve the discriminant first. So 12 squared is just 144. 4 times 1 times 21 is 84. So now inside here, we have 144 minus 84. So let's go ahead and rewrite what we have so far. We have x equals negative 12 still, plus or minus the square root of 144 minus 84 over, and then I'm just going to write 2 here because 2 times 1 is just 2. So 144 minus 84 is 60. So this is actually the square root of 60. Now let's go ahead and simplify this radical if we can. So I'm gonna just bring it out here, square root of 60. Simplifying 60 into its smallest factors, it looks like we have 2 and 30, and then 2 and 15, and then 3 and 5. So the square root of 60 actually breaks down into the square root of 2 times 2 times 3 times 5. Because the index here is invisible, that means that the index is 2. And so we can take out groups of 2. Here we have a group of 2 2's. So I'm going to take out a 2, and then I'm left with 3 times 5 inside of the radical, which is 15. So the square root of 60 can actually be rewritten as 2 times the square root of 15. So now we have negative 12 plus or minus 2 square root of 15 over 2. So now we have x equals negative 12 plus or minus 2 square root of 15 over 2. And we should notice here that these terms all have a factor of 2 that could be taken out. So let's go ahead and do that. Let's take out a 2 from the numerator first. And that's going to leave us with negative 6 plus or minus the square root of 15. And then the denominator is still 2. Now that we have the factor of 2 being multiplied to the factor of negative 6 plus or minus the square root of 15, we can cancel out the factor itself from the numerator and the denominator. Be careful doing this, guys, because a lot of students I've seen go ahead and cross out these two numbers, but these are not factors themselves. The 2 is a factor, but the 12 itself is not a factor. The 12 is being added or subtracted to something else, so you can't cancel these out just yet. You do have to make sure that it is a complete factor in and of itself before you cancel it out. So it looks like we're left here with x equals negative 6 plus or minus the square root of 15. You might see the answer like this on your test, or you might see it like this. It all just depends on how your professor writes the answer, but these both mean the exact same thing.